All right, so welcome to today's live stream, which is all about ARM templates. And today we will talk specifically about a little bit more complex ARM templates. So we'll dive into the depth of ARM templates, how they work, and how you can actually work using ARM templates a little bit deeper to actually create more complex stuff based on your requirements. 4 weeks ago, approx, I did 2 intro live streams for infrastructure as code, one covering ARM templates and one covering Terraform. This was really the introduction, and this now is the follow-up live stream. And what I actually did is I created a poll and asked, well, what specific topics you want to hear when it comes to ARM templates, and the results were pretty much equal, and so we decided to do all of them. So, and this is now that so-called live stream series about ARM templates, and it's the first live stream where we cover those more complex ARM templates. Because it's that many live streams, I decided to not do this alone, but I asked one of my good MVP friends, Martin, to join me and take care about all the demos today. And that's actually what he will do today. So, quick information about myself. My name is Marcel. I'm an Azure MVP and regional director. I operate out of Switzerland, and I help customers with onboarding to Azure, deploying workloads onto the Azure platform using infrastructure as code. I take care of governance topics, and so pretty much everything that is needed to onboard customers onto the Azure platform. And as I mentioned, with me today is Martin. So please, Martin, talk a little bit about yourself.
Yes, so thank you, Marcel. My name is Martin, and I also am Azure MVP, working for an MSP or service provider out in Norway, where I'm a tech lead for the Azure products that we provide. So also have a lot of content around management and that kind of stuff. So, and infrastructure as code. Also running Azure User Group Norway, and have done a lot of public speaking pre COVID-19. So that's why we're running live events in the virtual world now.
Correct. Correct. All right. So I will present like all the theoretical background of those advanced ARM templates, and Martin will do all the demos. So as I mentioned, this is a live stream series, so we'll host a total of 4 live streams. So the one today, then next week we'll talk about linked ARM templates, where we show you what that exactly is and where it has its advantages. Then the week after, we talk about deployment scripts, something pretty new when it comes to ARM templates. And then finally, in the last live stream, we will also have a look at the tool chain that you can use to release ARM templates or release code to your Azure platform using pipelines. So if you want to get access to these live streams, follow this link, tinycc/RMT streams, and this will bring you to the LinkedIn post that contains all the details. All right. So what we'll cover today is more or less this. So we'll talk about ARM template parameters, we'll talk about variables, and we'll show you how this actually works. We'll cover dependencies in ARM templates, functions, conditions, copy processes, and then at the very end we also added this topic that is called Bicep, and we'll talk a little bit about that later. So we'll not unveil what this actually means now. All right, so let's start with parameters. So when you start writing your ARM templates, it's very important that you think of ARM templates that you can reuse over and over again. So you don't want to have ARM templates that contain hard-coded values. Because let's say you create an ARM template that deploys a web application onto the Azure platform. And whenever you deploy the next web application, you want to make sure that you can reuse the same code over and over again. And that means you need to remove all hard-coded values, such as, let's say, the website name or the database name, those kind of things. But then, of course, because these values are needed at deployment time, you will then submit values for those parameters when you actually deploy the template. So you need to deploy the template, and at the time of deployment, submit the parameter values. Now, for using parameters, you need to define your parameters in the parameter section of your ARM template. And there's different types or data types of parameters, as you can see here. For instance, there's strings, which can be used, for instance, for names. There's integers, which means numbers, or bool values, bool parameters, which are true or false. And then there's some more. So really depending on the type of data you want to submit when you deploy an ARM template, you define the parameter data type. Now, what you can also do is restrict allowed values, which means that for some specific parameters, you want to restrict the values that someone can actually submit. And this is normally done when you have to submit specific values that the Azure platform can actually understand. So imagine you want to deploy a virtual machine. And now to keep this flexible, for instance, you want to submit the size of the virtual machine as a parameter. This works, but then of course you need to understand exactly what size values that Azure actually understands. And to make sure that the deployment doesn't fail because you might enter some value that is not accepted, you can restrict the allowed values to only predefined values or a list of predefined values that you can use to submit. And then there's also a default value that you can set, which means if a default value is configured in your ARM template and you do not submit a value, this value that is set as default will be used. But if you actually submit a value for this parameter, it will be overridden. So then your actual submitted value will take precedence. All right, now as I mentioned, if you have parameters in your ARM template, you need to submit the values during the deployment, so at deployment time. And then there's two different ways to do that. So number one is you can submit the values manually, which means if you start your template deployment, it will recognize that some values are missing, and it actually asks you on the command line to submit the values, right? But now, of course, this is very hard to manage. And specifically later, if you want to automate your deployments, this of course will not work. And this is where parameter files come into play, which are files that actually contain the values for your specific deployment. So the values are stored in a parameters file. And that makes it, again, super flexible because now you can use, for instance, the exact same code, so your ARM template, to deploy something. And if you have different environments, such as a production environment or a dev environment, you can have multiple parameter files with different values for the different environments. And in the background, you always deploy your exact same code. All right, so now let's have a look at parameters in the demo. So Martin.
So what Marcel was talking about in the beginning here is that using parameters, we can have more flexibility around the code that we write. So imagine me working, or don't imagine, I actually work for an MSP, and we have we provision the same resources for customers around the globe, and also for different type of companies. So we can have the same resource defined, but we can use different parameters for different customers. So we can then shape their environment to fit their needs, so to speak. So we define the first thing we need to do is to define the parameter itself within our ARM template. So this is done by using a parameter block, and then we would define what kind of what type the parameter is, and we can also add in some metadata to the parameter. This is also where we can set, for example, default values or validate the inputs which the user can type. And further, we will need to reference the parameter at the resource level in the template. So where I have storage account name defined as a template or as a parameter here, I will need to reference that within the resources block where I'm actually deploying the resources. If that makes sense, we can take a look at where I will supply my values, which is within a parameter file. So I'm using parameters and I'm putting in the value for the parameter storage account name, which is what was defined in the actual ARM template structure or skeleton, or what we want to call it. So we define the parameters in a parameter block, and then we reference the parameter in the resources block. In this case, we are using parameter for the storage account name, and then we will supply that within a parameters file. We should be able to deploy this to a resource group in Azure. I will show you that I will do that. Just first of all, I will need a resource group to deploy to, and I'm just going to copy this one. So I want to deploy that storage account to this resource group that I pre-created a few minutes ago. Add that in as the first group name. It's not there. So you can see that the template parameter file is defined here, and then we have the actual template file here. If we go into deployments, we will see that we have an ARM demo deployment, which was the name that I'm calling the actual deployment, and then it will deploy the storage account, which is now done. And that concludes the actual parameter demo. So we have a storage account now where we supplied the name of the storage account through a parameter file.
All right, cool. Thanks, Martin. So let's go to the next section. So we talked about parameters, and there's another thing in an ARM template or another section in the ARM template, which is named variables. And can sometimes be a little bit confusing. What's the difference between parameters and variables? Well, parameters are actually submitted during deployment time of the ARM template, while variables are used inside the ARM template to somehow simplify the code or the procedure to actually deploy your ARM templates. So normally variables are used to somehow construct values. And now what does that mean? So it's possible that you use some ARM templates functions, and we will talk about those in the next section, where you, for instance, take a parameters value input, and before you actually use it, you somehow modify it. So you add something to it. So as you can see in the example here, you could use a parameter value and then add some prefix before that value is then used as the name, for instance, to name a resource later in the code. Right. And especially if you use this value multiple times throughout your ARM template, it makes it much, much easier if you just calculate this new value once in the variable section, so that you can then easily reference to that variable value later in your code. So with that, we don't have to repeatedly do the construction or the calculation of those values in the code. Which also means if you somehow want to change this procedure, you just change it once in the variable section, and it will be used throughout your code. So that was what the variable actually are used for. Let's jump into the demo to see that. Martin. Martin, you're still on mute, I guess.
Yeah, typical. So we have the same file in the that we started with. So parameters and variables was actually my first demo, and I forgot to mention it in the first section. But anyway, as Marcel said, that when we reuse the for example, during multiple resource deployment, we want to use the same variables for example, location, which is defined in this variable section here. We have location, and like we do with parameters, we are referencing the variable section within the resources section, and that way the user can control his and her input, and we as writers of the actual template can control how we want to construct more of the complex scenarios, where we are going to show you a little bit later. But in this case, we are using a location, which is West Europe, as a string, but we can do more complex scenarios later where we can reference, for example, the already created resource group location, for example. So I don't think we need to deploy the same script once more, but we can show you how we can build up on this template in the next section. But I guess that is enough for variables at this point.
All right, thank you so much. Let me bring back my screen. There we go. All right, now another very important concept is dependencies, because depending on your resources you describe in your ARM templates, they might be dependent on each other, which means that if you have a look at this example, if you deploy a virtual network and the virtual network gateway, of course, for us, it's very clear that we first need to deploy the virtual network. And once the network is existing, we will deploy the virtual network gateways. But of course, for Azure, this is not clear at all. And that means that we need to define the dependency, saying, well, please first deploy the virtual network, and only if this deployed successfully, then start deploying the virtual network gateway. Right, so these dependencies are explicitly configured. And just one thing to keep in mind here, what lots of people do is when they start developing ARM templates, they start with one first resource, for instance, in this case, with a virtual network. And then they deploy it to see if that code works. And once it works, they add a second resource, which would be the virtual network gateway. And then they also deploy it without configuring a dependency. And what happens? The code will execute and deploy successfully, because even without configuring the dependencies, it will probably work because the virtual network is already sitting there. It's already existing in Azure. And then, of course, the ARM template will immediately start provisioning the virtual network. But then if you decommission everything or delete everything and then restart from scratch, the same ARM template that worked minutes before might now fail because now nothing exists and both resources need to be deployed from the very beginning. And then if you don't have these dependency configured correctly, yeah, you might run into an error. So dependencies are very important to take care of before you bring your ARM templates to production. And we'll have a quick look how this looks like.
So dependencies, where we are now entering kind of the level of ARM templating where it actually gets complex and interesting. And during development of your first or second or 10th ARM template, you will hit your bang your head on dependencies and the references and stuff like that. But as Marcel mentioned, if the resources already exist, you will think that the template that you're creating also will work because ARM will just redeploy or reconfigure the already existing resource. So I have continued to build up on the first template that we created. The new thing that it has entered this template is a container name. So within the storage account, I actually want to create a blob container. And I want that to be named images. So after my storage account, which is the same resource that we defined in the first template, I am adding in a child resource. This child resource has a extra property which is depends on, and it depends on it references the storage account name that was provided by the user at input. And this depends on will work because the resources is deployed in the same template. If it were depending on resources that were already existing in Azure, you will need to reference that when using functions within the template. So we could try to deploy this into the same resource group and see if the storage account actually will have a container once it is deployed. So I actually should rename the actual deployment, but see if the storage account now has a container. So now it has a container called images, and the reason for the deployment not to be listed as a second deployment is that the name of the actual deployment was the same. So that will just be updated within ARM as deployments actually are resources on top of the Azure Resource Manager. So that's how we are adding in child resources in this demo, and also how it depends on an existing, or in this case, storage accounts.
Yep, thank you so much, Martin. All right, so now it's getting interesting. So let's talk a little bit about functions. If you use ARM templates, they come with lots of different functions. I don't know how many functions are available. I would say close to 100, maybe it's even more, I don't know. But functions allow you to use some advanced logic. And you definitely need to follow the docs to actually start working with the functions, but we will cover just some of them to give you like some use cases. So for instance, there's string functions. So imagine you want to deploy a resource, and let's pick storage account, because that's a very good example. And you submit the value for the storage account name by using a parameter, which allows the person that actually executes and deploys the ARM template to submit some value. Now, the thing is that storage accounts only accept lowercase strings. So we need to make sure that this value that is submitted is actually first changed to lowercase only, to a lowercase only string. And this, for instance, could be done with a string function, which is called to lower. Right. Same is available for changing a value to uppercases, which would be to upper or something. Or you can use the split function to actually split a string into multiple parts and then use just a single part of that string. Or you could do the other way around and concat strings. That's also something that's used a lot to concatenate a new string based on different inputs. Right, so these, for instance, are string functions. Then there's comparison functions where you can check a condition saying, well, only if this value equals something, then do something, for instance, right? Or you have numeric functions that allow you to somehow work with numbers. For instance, add values or subtract values or divide values or whatever you need to do. Or you have logical functions where you can test some logics, for instance, if functions. So only if something is true, then continue to do that. All right. And then there's also so-called resource functions, which are very important. And I assume Martin will show in the demo afterwards one or two of these resource functions. Imagine you deploy a virtual machine, just as an example, and this virtual machine needs to be connected to a network that already exists on the Azure platform. So that virtual machine is new, but the virtual network is already sitting in Azure. And then, of course, we somehow need to instruct the ARM template to connect that virtual machine, or more specifically, the network card of that virtual machine to an already existing network. And so we somehow need to reference to an already existing resource that is living in Azure already. And for that, we also have different functions available that we can use for that. And if the default functions are not enough for you, there's also a possibility to write your own functions. They are called user-defined functions. And there's a section in an ARM template which is named functions. And this is a place where you can add your own functions, define the input values or input parameters for your own function, and define the output values for your own functions. And then you can trigger this function from within your template. So in case you want to build some advanced logic that you use multiple times within an ARM template, but it's too complex to be done in variables, then user functions would be the way to go. All right, so let's have a look at functions in the demo.
Thank you, Marcel. So functions, now we are entering what is, at least to me, both difficult and what I actually love about ARM templating, because when you start to use functions, you will quickly add value to your code, but you will also add complexity to the actual template. So it is good practice to actually study the Microsoft Docs and also build up start with the low-hanging fruits and then add in more complex scenarios as you go on. So what I usually do with the first templates that I create is to use resource group. I want all my resources to be deployed to the same location as the resource group is deployed. And then I can use resource group as a function itself and pull out the location. Then I can add that value into the resource variable. Which, if you remember in the first template, I was actually writing West Europe in string, and now I don't care if it's West Europe or Norway East. I just want it to be deployed in the resource group or in the same region as the resource group. And as Marcel said, the storage accounts need to be globally unique, and it also needs to be a lowercase only. So now I'm taking the user input from the parameter storage account name, and then I'm forcing all lowercase. So now I have moved the name reference from parameters and into variables instead. And then I can just make sure that the user can put in whatever he or she wants that to be named, and then we can control and set it to lowercase. If I split this into two sections actually, and I want to show you if we add in even more functions to our deployment. So now I am also asking the user if the environment should be what type of environment he or she is deploying, and I'm only allowing dev or prod as the input, and I'm setting a default value to be dev in this case. And now I'm also using a concatenation. So I'm adding in a prefix to my storage name. I want all storage name to start with str to kind of define what type of resource it is. So I'm concatenating the storage account name provided by the user, and I am adding str as a prefix to it. And then I am using the input parameter environment, and I'm using that as an additional tag. So the tag value will be what is defined in the environment tag. Now we have a little bit more complexity and a little bit more control over what is happening to our deployment. So let's see if we can make that work. So the tags are probably taking a little bit of time to show up, but deployment went through. We can go back and check that a little bit later in the next demo or something. I think that is okay for now.
All right, so very powerful thing, ARM template functions. Let's quickly switch back to a very, very short part. And this is about conditions. So this is really short. In case you don't want to provision specific resources that are defined in your ARM template all the time, you can use conditions. So saying, for instance, well, if this and this is true, then please deploy that resource. But if this is false, then do not deploy the resource. So for instance, you could have, just as an example, a redeploy parameter or a deploy parameter, which is a bool, which is actually true or false, or it can be a string, which is yes or no. And then you could actually use that in a condition that is used to check if a resource should actually be deployed in the next deployment or not. So the resource block will actually have this condition property that is checked before it gets actually touched, no matter if it's to deploy or just to reconfigure or analyze the resource. The conditions are always checked. Let's also have a look at that.
Let's see how that looks. So, but we can now use conditions, as Marcel said, to make sure we provision the correct environment, for example, or if we don't want to deploy the storage account, which is deployed in, if we want different configuration for different environment and that kind of stuff, we can use conditions. And we can use conditions in various ways. I have a few examples here. I'm just going to pop into the correct folder. So first of all, I am reusing the input parameter for environment. I'm going to use that for a different or build on top of it. I am also adding in more complexity by asking if the storage account should be open for network opening for within the Azure platform. And I'm still using the environment as the tag value for the tag environment. But now I am making sure that if the user wants to open up for Azure services at the network level for this storage account, they can provide that in the input. So if the user says yes to allow Azure services, I will do that. Or if they do not provide yes or write none, I will set none as the value for the bypass parameter or the bypass property, which is something that you can define on the storage account resource itself. But I'm also using condition at the very top level of the resource itself. So I only want this resource to be provisioned if the condition or environment says prod. So I'm using the input parameter to define if I'm going to deploy the resource at all. And I'm also using it for a tag value. And I am using allow Azure services parameter to allow or deny other Azure services to access this storage account. And if I want this to be actually, or if I want this template to actually run, I need to add in the environment parameter here. So I have not defined environment in the template file, so I need to add that in after or in just in as a parameter from PowerShell. As you can see within the template, while this is deploying, you can see that it has a lot of course, it has a lot of commenting in this template, but there's not a lot of hard-coded values now. Everything is constructed at runtime or provided by the user at input. Let's see if that's what's deployed. You can see that I have a conditions deployment. Now we have str as a prefix, and we have hopefully firewalls and virtual network configured to allow trusted Microsoft services. So that's something we can work on. Marcel?
Yep. So that's super interesting because it makes your deployments very, very flexible. All right, now the last thing we want to talk about before we switch over to Bicep is also a very powerful thing, which is called copy. Now imagine you need to deploy multiple instances of a specific resource. So for instance, if you need 20 storage accounts, if you set up a demo environment or a workshop environment or something, then of course, you could add 20 different storage account blocks into your code, but that's lots of code at the very end. And we want to reduce the amount of code as much as possible. And for that, we can use the copy function. And that means that we can just copy a specific resource block X amount of times. So let's say we need 10 storage accounts, then we just create 10 copies of the exact same code. Now, of course, if you create multiple instances, it's up to you to define, well, do you want to deploy all of these instances in parallel, or should they be deployed sequential? So that's up to you, and depending on your use case, parallel or sequential makes more sense. So that's your decision. But then a very important function is used together with copy, which is copy index, because of course, if you deploy 10 storage accounts, you know that every storage account needs to have a unique name. And by using the copy index function, this gives you back the iteration number of the resource or the copy process, which means for the first storage account that you will create, the copy index will be 0. For the second, the copy index will be 1. And then you can, of course, again, use the copy index to create the name, for instance, again, together with a concatenate function, where you can just concatenate some string that uses some input, such as storage account, and then add the copy index as a unique number at the very end. So copy and copy index, very interesting. And Martin will quickly show you how this works.
we want to create a bunch of storage accounts. I don't know why you want to do that, but for demo purposes, that's always what we want to do. So I need the user to provide how many storage accounts they want. I have a default value, so if you do not specify anything, you will get 5. And then we have the same stuff that we had in the previous demo, but now we need to add a bit more complexity to the actual deployment of the resources. So the condition still applies, but the name now has a copy index, like Marcel said. This will add, in the, as it stands out now, it will add 0, 1, 2, 3, and 4 to the storage account name. So it will get 5 storage accounts. And the actual copy is defined in this case at the bottom here. So it needs a name, and it needs a number of storage accounts. And the count could be also provided as an array, and then you can count the length of the strings in the array. Or so if you provide 5 different names in an array, you can have 5 storage accounts with 5 different names. And then, since we have a dependency for the container, we need to reference the copy index there as well, so they know which iteration of the storage account to deploy the container into. And then, just as a bonus, I added an output showing an object for each storage account, and we'll have the resource ID for that storage account returned. So hopefully now it will just spit out 5 resource IDs at some point. While we wait for it, is there anything you want to add in, Marcel?
No, that's perfect. The only thing I have to add is that we're running a little bit out of time.
Yeah, I see that.
So I suggest that we switch over to cover the last topic, which is Bicep.
Okay.
But as I can see, the storage accounts have been created, so that's great.
Yeah, so we have the output for the 5 storage accounts now. So Bicep, what do you want to talk about that? Is there anything you want to show on the slide, or should we just show how it looks?
Well, I will just very, very quickly go through the slides. It's only 2 slides.
Yep.
But just to give you some context here, I mean, we've now seen ARM templates, and the demos that Martin showed us are still like pretty simple. So hard code ARM templates are really, really tough to read, to maintain, to develop, to author. And you need quite some experience with JSON files so that you're able to easily read those ARM templates. And this is where Bicep comes into play. So it's kind of an additional abstraction of ARM templates that allows you to write your code in a different way, in a different format, in a different language. And once you have created your Bicep code, you then compile it to an ARM template. So it makes it much simpler to author new templates. And if you ever work with Terraform and think, well, Terraform is much easier than writing ARM templates, then this is where, well, Bicep somehow attaches. So it tries to give you like this very simplified authoring experience, which uses less code, gives you more transparency. But at the very end, if you have your biceps files ready, you will compile them to ARM templates, and that compilation process does all the hard work for you by putting your bicep configurations into an ARM template. So enough talking. Martin, show us how this works.
I will, just in a second. The thing is that Bicep at this point does not have all the functionality that we are used to with ARM templates. So I kind of moved back to almost the first demo, but just to show you the difference of how you build up the templates. So the whole point of Bicep is to simplify ARM basically, and it will reduce the number of characters that you need to type, not necessarily the lines of code, but it significantly reduce the number of characters, and also the complexity around referencing resources and that kind of stuff is now at least reduced. So just by looking at the input parameters here, you can see that you don't have the large block to define one parameter, for example. Just putting in the name, equal sign, and then the default value. So this is a default value, and then if the user provide that an input, it will just overwrite or use the input as the parameter value. And also here I am using a concatenation type. So they have simplified how we can manipulate strings. And also they have, like I said, they have reduced the number of characters basically. And so if I want to check if this is a production environment or not, I can provide a Boolean value or a Boolean parameter, and then we can use that to manipulate how we want to deploy the resource. But as Marcel said, Azure itself cannot handle the Bicep file as a deployment file, so we need to create ARM templates out of it. And then we use that, and we do that by installing AC Bicep, and then we can use run Bicep build and the input name of the file. So I want to build main.bicep, and it will output the ARM template for me as the name.json. And then we can see how much more verbose ARM is over Bicep, just by looking at these two files. So I'm really looking forward to starting to play more around Bicep in production once it's ready for that. Marcel?
Yep. Yeah, I think that's an important one. So Bicep is version 0.1, so don't use it yet in production, but you can already start playing with it now. And we'll see some extensions for Biceps very soon. Actually, we should talk about running a specific Bicep live stream maybe after this series ended, but we'll just discuss that later. But it's definitely a great addition to your authoring experience. So now, very important, if you want to get access to all the demos that Martin showed you, this is the URL where you can get access to the repository. Thanks, Martin, for sharing your code. So that allows you to actually play with everything that you've just seen yourself in your environment. And then there's this thing that we were handed over by Microsoft Dev. Have a look at those two links. So start using well, this the so-called Azure Heroes program, which allows you to collect badges, which is very cool because you have like great learning experiences on that platform. And what we will do, if you promise to actually visit those two links, we'll pull a winner out of today's attendees, and that winner, which will be drawn by some random process, will actually receive a swag pack from Microsoft, and it will be delivered to your home address. So if you're the winner, we'll get in contact with you very soon, and then you can enjoy this, well, this swag from Microsoft. So very cool, actually. So thanks, Microsoft Norway, for making this possible. So that was it. Lots of information. We'll continue next week with the next topic, linked ARM templates. Again, make sure that you have this shortened URL available to access all the details and to register yourself. All right, and that said, I hope it was worth joining us today. And if I take a look at my watch, it's now, well, we're just in time, I guess. Yeah, thanks everyone for joining. I hope this was valuable and you could learn a little bit more about ARM templates. And as we said, be back next week to learn everything about linked ARM templates. Thanks, Martin, for all the demos, and see you all next week. Thank you. Bye-bye.
Bye.